Right. Good afternoon, everyone. I'm Ehab Syed. I'm the founder and chief evolution officer at Biome. And today I'd like to talk about how we can work towards a biomimetic future. Now, biomimetics or biomimicry is often defined as the emulation of natural and biological systems on the planet Earth in order to address some of the most pressing challenges for humanity. However, as we dive deeper into the definitions of nature, we begin to see how deeply interconnected all systems around us are. We see that changes in one system can result in a series of changes in all of the systems around it. And these systems regulate each other through a series of feedback loops. This deep interconnectedness has us redefining nature as the whole universe, as it is the place, the source, and the result of material phenomena. This includes humans, human culture, and human artifacts, and the result of human activity, reuniting humans and nature as one. With this redefinition of nature expanding throughout the entire universe and beyond just biological nature, we can go back to the beginning of time and see how through cosmic evolution for 14 billion years, systems have been evolving and emerging and responding to their external environments. They've been extracting energy from their external environment in order to complexify and develop further. And thanks to American astrophysicist Eric J. Chason, we can begin to empirically measure the age-old notion of energy being at the source of all material things. And that's not just for material things, but it's also for systems like cultural systems and intangible systems around us. We can look at how much energy is being passed through a gram of a system within a second. And with energy rate densities, we can begin to also correlate the level of energy being processed with the complexity of a system. So we can see energy rate densities as the metabolism of systems around us. And I want to remind us of the second law of thermodynamics. When energy changes from one form to another, entropy or disorder always increases. Now keep that in the back of our minds and let's go to the beginning of time, to some of the earliest systems that ever emerged. Galaxies have an energy rate density of about 0.1. The sun and stars are slightly higher. The sun's at around 2. And then our Earth emerged, and the climosphere, or the exterior of the Earth, sits at around 75 ergs per second per gram. Biological evolution came along, and we saw a whole new order of magnitude in complexity and energy rate density. And then mammals came along at 40,000 ergs per second per gram. Humans have a much more efficient body, so we sit at around 20,000. And then the most complex biological system known to us in the universe sits at around 150,000 ergs per second per gram. We put our brains together and created agriculturalist societies. Each member of that society uses around 100,000 ergs per second per gram. We then tripled our energy rate density with the Industrial Revolution and created some machines and automobiles that sit at around 1 million ergs per second per gram. That just demonstrates the level of complexity as well as the amount of energy being consumed by these machines. Every one of us sat in this room today or in this entire conference is using about 2 million ergs per second per gram. We created artificial intelligence and entered into a whole new order of magnitude of 10 million ergs per second per gram. We put all of this on the chart, and when we see it all aligned together, we see that since our arrival, complexity has increased at almost a vertical incline. A rise in energy rate densities means that there's a huge amount of energy being transformed. And that is because we are one of the first systems in the universe known to us that is practicing reflexivity in a conscious manner. We're able to reflect on the past and the present consciously and inform the future. Unlike other natural systems, which just respond to the feedback loops and the interconnectedness of the systems around them. Whilst we were once very much in tune with the natural order of things in nature, we stumbled upon the most concentrated source of energy in the universe, fossil fuels. And when we're transforming huge amounts of energy, It's no surprise that there's so much entropy or disorder in our environment. The climate crisis, the biodiversity loss, the pandemic, and the extreme climate impact that we're seeing around us are all just the result of these systems that we have created and the major transformation of energy. This drives us to redefine biomimicry or biomimetics as the holistic and systemic emulation of the multitudinous hierarchical systems in nature, which is the whole universe, to create intelligent solutions. And intelligence being defined as being locally situated, so conscious of the global and local context, socially connected, and sensitive to the cybernetics and energetics of our environments. In short, it enables us to master the reflexivity of life. And that's exactly what we do at Biome. Biome is a multi-award winning research and development-led company that places natural systems at the heart of its inspiration to reharmonize cultural and natural systems. We're driven by a very simple philosophy: to allow nature to lead innovation and only have a positive or regenerative impact on everything we touch. And this philosophy is manifested throughout all of our core biotechnologies. Starting with our materials, mycelium, we work with one of the most wondrous organisms in the world, fungi, and in particular, we work with the root structure of fungi. We take species or strains from the wild, and then we evolve them on a genetic level in order to achieve properties that are unprecedented for natural materials and construction. And then we also tweak the environment in which the materials are growing, and then also post-process them. This has enabled us to create a mushroom or mycelium-based insulation material for construction, which is currently being scaled with one of the largest construction firms in the world. And as we were evolving our strains on a genetic level, we realized that some of our strains have developed an appetite for plastic. Not only are they outperforming conventional materials that are established in the industry when it comes to standards and construction standards, but they're also able to consume waste streams as they're growing. So we feed our mycelium insulation hemp, and then the strains that we have discovered can actually consume plastic. We realize that it can consume polyurethane, polyethylene, and polystyrene, as well as polyester, some of the most problematic plastics in the world. And these strains are consuming plastic at such a rapid rate that polystyrene was no longer recognizable under chemical analysis after only 28 days of exposure to our strains. We also developed ORB, or organic refuse biocompound, and it's a material that enables you to go anywhere in the world and find an agricultural or food waste stream and then transform it into a high commodity material or product. Our obscure lampshades are just an example of how orange peel or coffee chaff, major industrial waste streams that are problematic because of their acidity, can be transformed into carbon negative materials. By just integrating these materials in your properties, property developers are able to decarbonize their builds. Recently, we've made some revelations in the ORB technology where we were actually able to transform orange peel into tiles or a material without any binders. So that's 100% orange peels that you're looking at. Triagamy is another technology we've developed, and it's inspired by the mathematical geometry that lies at the molecular bonds between carbon molecules. It is a construction system that enables buildings to be deconstructed or reconstructed at any stage of their life. It combines all of our materials, making its environmental impact when compared to brick and block construction a reduction in environmental impact of 120%. It reduces build times by 95% and build costs by 70%. Now, triagamy enables us to work towards agile infrastructure. Much like in nature, infrastructure responds to the organisms around it and is able to allow us to transform cities in real time. All of our systems and technologies are patented globally, and we work to license them to large multinationals in order to scale them around the world. And we also carry out some transdisciplinary biomimetic research. For example, we transformed soil from a construction site into a material that could then be turned into product and put right back into that same site, the buildings on the same site. We also did the same for Glyndebourne Pavilion. Their waste streams were champagne corks and oyster shells and grass from their fields, and we were able to transform that into material that could be used for interior facades. We worked with human hair, one of the most interesting waste streams we've ever worked with. Our scientists weren't very happy with working with the human hair from salon waste, but it was a really interesting waste stream that you get about 2 tons per month from just 4 salons in London. And we transformed it into a material that was kind of like a carpet. We also looked at the most problematic waste streams that come out of a construction site during construction, as well as during the operational phase of a building. Those include things like coffee grounds, cardboard, pulp, packaging, OSB, timber, mineral wool, ceiling tiles, and we were able to match them with each of our biotechnologies in order to create new materials. We transformed the polystyrene, we broke down the polystyrene used in our mycelium strains, and we transformed the wood waste and the cardboard and the coffee grinds into materials that could be used in construction. We also worked with Bupa, where we worked on PPE, or face masks and gloves, where we could actually take those waste streams that were being produced at such a high quantity during the pandemic and completely break them down using our mycelium strains. And we're currently working with the Biomimicry Institute to integrate bacteria into our technology to look at a wide range of chemicals and toxins found within the fashion industry in clothing, breaking them down and then breaking the polyester and cotton mix fabrics down as well. We've been awarded and recognized by multiple bodies globally and nationally in the UK. And we're working towards a biomimetic future with major multinationals, government, communities, in order to not only see biomimetics present in the legs of a robotic dog that has an ever-increasing capacity for mass destruction, but instead have it be in our mindset, in our thinking, transform the way that we think into one that is holistic and systemic, and enable biomimicry, enable biomimicry to be present in our thinking and in all of our technologies. And that will hopefully enable us to change the narrative of humanity in the story of evolution from one that is impeding the evolutionary rights of other species on Earth to one that is actually supporting and regenerating the evolution of all organisms around us. And that brings me to the end of my presentation. Thank you all very much.
Okay, I think tech is, we figured you good? Woo, okay, great. Hi, I hate following Ahab. It's absolutely horrible, and I will not be as profound, sadly. But hopefully I can still be interesting. So my name's Brittany. I'm co-founder and CEO of Colislow. Hello. And we are the simplest way to decarbonize construction. And we're doing that not just only by making them generate less carbon, generate less waste, but also hopefully saving them time and money in the process, because unfortunately we live in a capitalist society, as much as we hate it, and we need to be able to do that too. But before we dive into exactly how we do that, I wanted to take a quick poll. How many people here have heard of urban mining? Oh, that is a really good number. You did not put your hand up last week. That's only because you've just heard this. The clicker doesn't seem to be working, just to shout that out. Oh, it is now. Or is that your one? Oh, well, fine. Cool. So there was actually quite a good number of hands there. Now, as you probably know, the construction industry consumes around 40% of the world's resources each day, year, however you want to measure it. And that's because we're mining, we're felling trees, we're doing all kinds of things. Now, in that process, the built environment is responsible for around 40% of carbon emissions, and by the way, we generate around 40% of landfill waste. So for some reason, 40 is quite a big number for us. Yep, we are not great as an industry. But where we want to get to is that actually we stop mining from the earth, and actually we start working towards a way that we are constantly mining our buildings, mining this space. And you've obviously seen the massive construction going on outside. There's such opportunity in these spaces for us to start building from the resources that we already have. Why is this so important for construction today? Well, we've got a lot of regulation coming in. Some people may have heard of the PPN 0621, possibly the sexiest name regulation in the UK. No, no one finds that? Okay, fine. Ultimately, what it's saying is if you're on public projects over 5 million, you've got to start reporting on and measuring your carbon. Most people haven't heard of it yet, which is actually slightly terrifying, because if you are bidding on public projects, you are actually responsible to it. We also have Part Z, which has been in and out and in and out and in and out of Parliament, and hopefully at some point it will come into play, because that will drive a lot of change. Everyone hopefully here has heard of the golden thread, mandating that we have a clear picture of the materials that are going into our buildings, making sure that they are safe more than anything else, but also that they are responsibly sourced. And then finally, we have a responsibility as an industry to actually pay people on time and be legitimate in the way that we source our supply chain. All of this means a lot more reporting, a lot more data collection, and a lot more paperwork. How many people here work on a construction site or have been on a construction site? Yeah, quite a few. How many of you love doing paperwork? None, didn't think so. Absolute pain in the backside. This is because that process at the moment relies entirely on collecting paper-based systems, either because your supply chain are manually putting them into systems, or because you are actually doing that heavy lifting as well, which wastes a lot of time, causes a lot of errors to be introduced, because although our brains are like machines, we are terrible at data processing, and it ultimately costs our industry hundreds of thousands of pounds for each project. So with Qflow, we're overhauling that. We're trying to make it as simple and straightforward, as easy as 1, 2, 3, to capture that information and put it into the systems that you need in order to make sure that you understand the materials going into your site and the waste coming out. Now, all of this is the foundation to urban mining. So what does that actually look like on a construction site? Well, a truck delivers some materials, the site team take a photograph, that flies into our systems, and we use machine learning to extract the information from that photograph and structure it into a database. We then audit that against the project's requirements, so if you're going for BREEAM, LEED, WELL, whatever certification you fancy, we flag when something's wrong, so you can actually act on that information in real time. That then flies into whatever preferred reporting system you are going for. We're not precious. And that means that your project teams aren't spending hours, days, chasing paperwork and typing it into different systems. It's all done automatically by the machine. What that means is that instead of getting frustrated and stressed out on a Friday night trying to chase information from your supply chain, you're actually able to take that information and turn it into action so that you can cut carbon in real time. So we work with the UK's leading contractors and developers. We've just started working with Australia and the US as well, which has been quite a quick turnaround and something that is genuinely terrifying, but also amazing fun. And what we're working towards is an industry where not only we understand what went into our buildings, but a way that we can understand how we keep them there for longer and that we reuse them within our built environment. So Qflow is that foundational data that makes understanding the impact of our industry far more straightforward, but also more cost-effective, so that we understand our baseline and we understand where we have an opportunity to have an impact. What this looks like in reality today for construction projects is knowing exactly what's going on across your supply chain without having to chase them, which is really nice, because no one likes being on the phone to a slightly angry contractor. It also means that you can keep real-time overview of whatever certification you're going for, and I know there are lots of Marmite relationships with things like BREEAM and LEED, but they're there and they're things that we use to measure progress. They're also helping to understand our impact on the waste side of things. And there's a report coming out in a couple of weeks' time that looks specifically at the UK's waste impact from the construction industry and how we can focus our efforts with our supply chain to reduce the impact of our impact on waste, and how we can make sure that ultimately we're not contributing 40% to landfill, and actually that can turn into feedstock for amazing other startups and innovators who are transforming the way that we build. And finally, and I know obviously we're at a conference all about decarbonisation, but it means that we have a really clear picture, not just of our scope 1 and 2, but also our scope 3 carbon. And for the construction industry, that is 90%. 90% of our carbon is scope 3 across our supply chain. And so if we have any chance of decarbonising what we do, we need to be looking at this piece. So we've been working on sites not far from here, on the other side of London, looking at major commercial developments on how you can improve the responsible sourcing of things like timber, which is a huge, huge material supply for our industry, but also delivering actual cost and time savings, which means that as an industry, it's not only the right thing to do, but it's the right business thing to do to make sure that we're operating more sustainably. We don't just work with commercial developments, we also work with major infrastructure, and no matter your opinions on HS2, I think ultimately we want it to be more sustainable at the end of it being built, if it gets built. And so we're still working with some of the heavy civil industries as well. So now we know what went into these developments, whether they're big event spaces like this or major infrastructure projects. We also know what we can take back out. Not only can we see where we have an impact today and the embodied carbon of per square foot of our real estate, we also know what's available for the other people in this space who might use them as feedstock for their material supplies chains, or where you might be able to send them back to the manufacturer and supplier for re-warranty and remanufacturing so that it can be used at its very highest level of value, so that it's not just recycled. Ultimately meaning that we're no longer building from raw materials extracted from the planet, causing environmental degradation and social impacts. We're ultimately building from within our own built environment, drastically reducing our carbon impact and our contribution to waste. This is urban mining for the construction industry, and this is the way that we build a more sustainable future. So if you want to find out any more, we're over just down the corridor, and I will be here afterwards, and I'm more than happy to field any questions if we have time. Any questions? I think we've got a couple of minutes. Stunned silence. Oh, yeah, sorry. Hi.
So mostly for this, for urban mining, you're talking about future. So you're talking about the structures in the future that we'll be able to extract from. Do you have any type of system or backtrack system of the current buildings that we can use the materials from or where they come from, but what we can do today to use the recycled materials instead of take raw materials?
I'll use both. Yeah, really good question. So today we're not sort of tracking existing buildings in the way that QFlow works, but there are some amazing companies that are doing internal scannings. The challenge with that is you're only getting a skin deep picture. So what QFlow is doing is obviously tracking the materials as they're being stripped out, currently classed as waste, but we're looking at ways that we integrate with other systems like GlobeChain and circular marketplaces to put that back into the system where we can. We also work on a lot of fit-out projects, and the sort of life cycle of those projects is sort of 3 to 5 years at the moment. Tenancies tend to be quite short, and so actually the value of this data gets realised very quickly. There are projects we were on 2 years ago which are starting to be put out as an idea of refitting them. And so that's where that data then feeds directly into that circular economy piece. Where we'd like to get to is where we've been deployed on hundreds and hundreds and hundreds of projects, is we'll have a really rich picture of what buildings typically look like when they're taken down. And so statistically, we hope to be able to identify the sort of high-level ideas around the amount of bricks, floor tiles, doors that are typically in a building of a certain size. Now that requires big data to be able to do that, and it's something that we're working on with other startups and innovators in the space to try and get more and more information around and integrate our data systems with theirs to really unlock that potential. We are one piece of the puzzle in terms of building that foundational data layer, but we integrate ruthlessly with people to try and make sure that this is a streamlined and efficient process for the industry. Any other questions? No. Great.
Perfect. Good afternoon, everyone. My name is Nigel Banks. I'm Research and Development Director at Ilke Homes. I've got a slightly different presentation again to the previous two, but hopefully also showcasing what can be done and inspiring around where we're going. So picking up around the focus around embodied carbon, but also around what we're doing on operational carbon and delivering zero carbon homes. So I've come down today from our factory in North Yorkshire, where the yellow pages used to be printed, not printed anymore. And we now employ 1,100 people in the business who have come from outside of the construction sector to build modular homes. So this is a typical module that comes out of our factory. This was being installed in the centre of Manchester 5 years ago when we first set the business up as a demonstrator. So we fully finish the whole floor of a house in the factory. So we're bringing modern manufacturing that's been applied to every sector in the world, apart from construction, and really bring it into house building. So there's a ground floor module with the bricks on the outside, with the kitchen, downstairs toilet, all fitted in the factory. So we have a team of people working in a nice big long factory there, where they used to print the yellow pages, and 95% of the roles have come from outside of construction. So we're not recruiting people off building sites and putting them in the factory. We're bringing people from outside the construction sector. So we've got people who used to work in retail, in call centres. We've got a former nun who works for us in the finishing area. So a really much more diverse labour pool. So we're at 20% women in the workforce. Traditional construction is 0.4% women in trade skills. So really are bringing additionality, so enabling us to build more homes. And we've been doing this for 5 years. We've built on 40 odd sites across the country for major house builders like Vistry in Bristol here, as well as for housing associations. So this site, hopefully this will play, yeah, is a site in Nottingham, right by the railway station. 42 homes delivered within a year. Normally that process and that site would take around 2 years to complete, but from planning permission to handovers was a year. But one of the big things that been talked about is the upfront carbon emissions and the upfront carbon emissions associated with construction. And we've had a big focus around how we can reduce our emissions upfront and on a life cycle basis. So this is a report that the Future Homes Hub put out earlier this year. They got most of the major house builders to put forward the embodied carbon analysis they've done to date. And we put ours in. Ours are the orange dots. We use a galvanized steel frame, which I think some people would naturally think would be higher embodied carbon than timber frame. And certainly lower carbon than brick and block. But what you actually see is a real mixture. And that's largely because the efficiency of your design has a huge impact on the upfront embodied carbon of your products. So we have an extremely efficient design with a hybrid of steel and concrete, hybrid of steel and timber. There's no concrete in our structures. And this report from iStruct really points out that timber can be lower carbon if it's used efficiently, but used inefficiently, as you often see in mass timber, cross-laminated timber structures on low-rise housing, you've got far too much material than you actually need for your structure. And we haven't got the time to allow the sequestering of the new tree that's planted to reduce our emissions. We need to be reducing our emissions in the next 10 to 15 years. So that life cycle there is a 60-year cycle. We need to be reducing emissions in the next 10 to 15 years. So we've done a lot of work on this. We benchmarked ourselves against a traditional build, and which is typically around 25 tons, the top of the chart. Our first design was around 20 tons. We made a further saving of about another 15 to 20% last year with our refresh design in our A1 to A3 upfront carbon. And we're now looking at where we can go further. We've identified a route to halving our emissions, and we published that in the Journal of Building Engineering last month. And we're now looking at where do we go beyond that. And some of the solutions there go beyond what we can actually do ourselves as a manufacturer. We're relying on our supply chain decarbonising. When will glass decarbonise? When will steel decarbonise? When will some of these other materials, plasterboard materials, decarbonise? Or will alternatives come to the market in order to deliver a zero embodied carbon house? Because it certainly isn't possible today. I think the closest you can get is an igloo when you make it in the winter. So the embodied carbon is a key piece, but also there's a big debate in some of the earlier presentations today around the operational carbon versus the embodied carbon and where's the right balance. And we think we're striking a good balance, but one of the things we're keen to do is engage our customers in carbon, and generally they're not that engaged. I think the people in the room here probably are, but generally they aren't. So the bit we've been focusing on is energy bills, and we now have the first guaranteed zero energy bill house. We've partnered with Octopus Energy, and these two homes are now occupied in Stanville Hope in Essex, and they are receiving a zero energy bill that's guaranteed for at least 5 years, but expected to roll on an ongoing basis. We're monitoring the performance of the homes closely, and they are outperforming the projections, using less than was predicted and generating pretty much what we expected. So these homes generate around 20 to 30% more energy than they use on an annual cycle basis, and that enables Octopus to guarantee a zero bill by managing when that energy is imported and exported to the grid. So we have a 10 kilowatt battery and a hot water cylinder to manage the heating and electricity usage in the home. So it can be done, it is being done, and Octopus are looking to roll that out with house builders across the country and potentially around the world, because Octopus are running in 8 countries. One of the big things we look to do is obviously we manufacture our housing modules, the sort of occupied spaces, but we're also now manufacturing our roof modules with the solar panels built in the factory with an in-roof system on both sides of the roof, which means we can orientate in any direction on a site and generate a very similar amount of energy. But coming back to embodied carbon, one of the key questions is that is adding extra carbon into the construction, adding a battery, adding solar panels. We do lay them in the roof, so we do get rid of the concrete roof tiles, but we are adding carbon. And one of the key things there is are we saving enough carbon to offset that additional upfront carbon? And the analysis we've done shows that we are, but we need to be very careful. As the grid goes to zero carbon and decarbonises over time, the savings reduce, and therefore the products you're buying need to be lower carbon. So as we move forward, the solar panels themselves, the manufacturing process needs to be lower carbon, the shipping of them to here, etc., needs to decarbonise. And where we are today, we see that payback period being within the first 3 or 4 years, and then overall savings on an ongoing basis. We'll need to keep an eye on that over time going forward, but that is for the solar PV and battery system that's applied to a home. It is essentially up to 4 tons of extra carbon up front. But it is paying back and saving about a ton of carbon a year at the moment, but that will change over time. One of the things we have also got to look at is we are fitting solar panels in our homes. If we're not fitting them in our homes, where else are we going to fit them? The UK needs to move from about 10 gigawatts of solar to about 50 gigawatts of solar. Our view is it's better to fit that on the roof of a house than on a steel or aluminium frame in a field. And we've got lots of houses that we need to build and retrofit, and therefore it makes sense to do that in the home. So I hope that's given you a bit of an overview around what we're doing at Ilka and how we're tackling both the embodied carbon challenge and what we can do ourselves, and seeing where we need the industry to decarbonise, and also what we're doing around operational carbon and understanding the balance between the two. And we really think the zero bills proposition is one which will hopefully take off in the UK and hopefully around the world. Thank you. Question?
Thank you. Fascinating to see the traction that you're having. I mean, MMC is definitely fundamental if we are to solve the housing crisis in the UK, no? So really well done. What is driving this demand? Is it price? Is it speed? We talked a lot about, or you talk a lot about sustainability, or is it sustainability, or all of the above? And if so, which one plays more of a stronger driver for demand?
So I think the Ilka business was set up on the back of struggling to find supply chain, particularly in the southeast of England. So I think there is a need for the solution, but the solution only works if it stacks up financially, and you've got the land and the supply chain and the routes to market to make it work. And I think that's where some of the others have failed, building the pipeline, gaining access to land, and being competitively priced. So I think that's a big focus. Any manufacturing operation has a very heavy upfront investment requirement, and you have to get to scale to make that factory work. So our factory is sized for 2,000 homes a year. We're currently doing 1,000 homes a year, so we need to be about 1,400 homes a year to break even. So we're not quite there yet, and that's one of the key things when setting up a new manufacturing plant. They're typically 100 to 500 million pound investment, a new gigafactory that has been talked about potentially in the UK, sort of 500 million to £1 billion of upfront investment, and that pays back through the but you need to fill that factory, and that's probably where people have struggled today. But that's one of the key things we need to do is guarantee the demand for that factory. We now have a pipeline of 4,000 homes worth about £1 billion, so we've got a good pipeline ahead of us. But yeah, you've got to be cost effective, and you really have got to focus on that and making sure the product is what people want. And we're certainly seeing a lot of traction in terms of people wanting our product. The planning system doesn't help, but we are getting through to volume. Thanks.
Hi, thanks so much, everyone. And just kind of maybe a question for all, but I guess one of the things is that a lot of the new construction methods or new ways of building tend to be kind of in relatively low rise, And I guess there's complexities that come up when you kind of talking about high-rise buildings. I mean, how do you see that evolving, changing over time, possibly?
Yeah, so I think we're focused on the low-rise sector. There's a company called Vision who have built a 44-story fully modular solution in Croydon. So you definitely can go high-rise with modular. You need to set up for that, and you need to have the products designed for that. Our product's designed for low-rise, but other people are designed for high-rise. I don't know if anyone else has got anything else to add on. I presume for your systems, it works on any solution.
Cool, thanks. This was very inspiring. My question would be, what kind of price premium do you see of a zero bills house versus a normal house?
So we are seeing people able to borrow more money to buy a zero bills house than they would do a standard house. The reason for that is when your mortgage company assesses how much money they will lend to you, if your energy bill is guaranteed to be zero, that's £2,000 less a year than someone would spend on a existing typical house. So that £2,000 is taken into your mortgage stress test and affordability test. So people are being able to borrow £30,000 to £40,000 extra for a zero bills house. The houses on the screen there have sold for between £20,000 and £30,000 more in Essex than the building regs comparable house, which is also on that site. So we have a direct comparison, and that's on shared ownership as well as open market sales. So we are seeing a sales premium that's really helped by the fact that mortgage lenders are putting a zero bill into their affordability check, so you can borrow more money. But the guarantee on the zero bill enables that. Average EPC, we're off the top of the scale A with the zero bill.
Just a quick question from me. You said you've got 4,000 homes in your pipeline. Over what time period are you looking to produce them and build them all, given, and linking that back to the point that you made, that the longer we wait, the less the return in the carbon for the zero bill homes?
So we're currently building 1,000 homes a year, and we're ramping up the factory to get to 2,000 homes a year within the next 18 months. So we've got a current pipeline of about two to 3 years ahead of us. Fundamentally, the UK needs a lot more housing, and we're trying to support that drive. The marketplace at the moment is less helpful, and the planning system is also probably less helpful. The challenge we've got is, if we build the volume of houses we need at the current carbon intensity we have, we will burn through our carbon budget quickly. So we do need to move very quickly down that journey and look at alternative solutions. And that's one of the things that we're trying to show how that can be done. But we've got to move the entire sector forward as well. So it's definitely a sector. Hopefully we can provide some inspiration around that. Thank you.
Thank you very much.